Todd Dunn here on November 22nd, 2019. Today I finally acquired all of the parts for my solar battery backup power system, and I'm going to start the final install. So let's take a look at where I'm going to be working. This is inside my utility room in the house. Right here is the combi boiler that provides our heating system. You can see all the piping down there. And right here is where I'm going to mount the inverter. And what you see there is 2 layers of 1/2-inch plywood. The first piece is screwed to the wall with 10 2.5-inch screws that go into studs. There are 2 lines of them, 5 on one side, 5 on the other. And then because 1/2-inch plywood doesn't give much purchase for screws that I'm screwing to, I epoxied a second layer of 1/2-inch plywood to the first layer, and the inverter will be mounted on that. However, because the inverter is not supposed to be mounted on a flammable surface, and plywood certainly counts as flammable, I'm going to face that with galvanized sheet metal. So that's the next step. I've got to do a little bit of sanding on that because it's got some epoxy filler here and there. I'm going to sand it smooth, and I'm going to put the galvanized sheet metal on. Now, because this is a very tight spot, there's no place I can put the camera where you would see anything other than my back while I'm working in there. So what I'll do is I will shoot some video explaining what I'm going to do. I'll do it, then we'll take a look at the result. Okay, here is the non-flammable backing for the inverter. That's a 26 gauge steel that is galvanized, and that is screwed to the plywood, which, as I said, is 2 sheets of 1/2-inch plywood epoxy together, and the screws that hold this on go through both sheets, so they assist the epoxy in holding everything together. So next step is to start doing the mounting of the inverter itself. Okay, I've got the inverter mounting bracket here on, and the inverter has holes in its frame that slide over these 4 stainless steel studs here. And unfortunately, the inverter weighs 62 pounds, so it would be a bit of a chore to get it lined up on these studs and then hold it up with one hand while you get the nuts started. So rather than do that, I've stacked up a bunch of wood and a piece of the foam that the inverter was packed with to pretty much the height that the inverter is going to be at when it's ready to slide on there. So what I'm going to do is bring the inverter in, make a couple measurements, see if I need to adjust this stack of wood, and then when I'm ready, I'll stand it up on the wood and on top of that foam and slide it into place. So all I have to do is keep it from tilting out, which shouldn't be that difficult. And I have the nuts all set out, and I'm just now going to get my socket wrench out to the appropriate size for these nuts. Okay, let's put the inverter on. That's it. She's mounted. Now all I have to do is get all this stuff out from under it. This could be a challenge, but not so bad. There she is, hanging on the wall. So I'll get all this wood put away, and we can move on to the next step, which is to start installing some of the additional components. So that wasn't as bad as I thought it was going to be. My setting it on a foam pad worked perfectly to hold it up and not risk damaging the inverter. The next step is to do the AC wiring, which is over here. I'm going to have to get a brighter light to put in here so I can see what I'm doing. And there are knockouts on the bottom down here where I'll bring the wire in. And what I'm going to, the AC from the grid is going to come in from over on this wall. There's a panel right behind this wall, so I'll be able to go into that panel, put the cable across and up there, and the AC out is going to go up here into my transfer switch right here. And what I'm going to do is just put a generator cord from the inverter so that I can plug it in there And if my batteries ever go flat, I can simply unplug the inverter and plug my generator in without having to worry about backfeeding the inverter or anything like that. The inverter will be completely out of the system. And I have a cord. All I have to do is cut it off and attach one end here after I get the length appropriate. So that's what I'm going to do now, is do the wiring for that. I'm not actually going to hook it up to the grid AC yet until I'm ready to power it up, because I don't want the chance, however remote, that I'll have hot leads in there that'll be a bit of a nuisance. So I'm going to get some more light in here and do that. Well, after much fighting, I finally got the AC wires connected. There's very little room in there. Tried to come in through the knockouts in the bottom of the inverter, but they're so far down from the openings that there's no way I could put the strain relief nuts on and snug them down. I simply couldn't do it. So I had to come in from the side, which meant that I had to make right angle turns with all my wires, and it was a bear to get them to bend in. So anyway, I'm going to knock off for tonight, because working in here in the room where my boiler is, it's really hot, and this has been a real pain. There's very little space in there and it's difficult to make the connections. But they're finally done, and tomorrow I'll work on getting the AC finished. I have to feed it over and into the panel, and then I'll start doing the DC wiring, which is going to take a little while, but should be much easier because everything will be out in the open. So I'm going to knock off for now and come back tomorrow morning. Well, it's the next day, November 23rd. Last night I finished attaching the AC wiring here, as I said in the last segment, and today I'm starting to do the DC wiring, and I'm also going to connect the AC wiring into the back of the panel. I do have one little issue there, in that the person who put the panel in originally made a mistake in installing a component, so I'm going to have to fix that before I can put the circuit breaker for this guy in. But that won't be that big a deal, just have to make the change. So that's where we are right now, and hopefully we'll get all that fixed and get the DC wiring done today and get everything ready to go, and so I can turn this thing on and get it all programmed. First thing I've done is I have crimped up some wires here for the primary DC wiring to the inverter, and I have to install the intermediate components, which is going to be a shunt in the negative wire. Then it'll go to the battery box, and the positive wire will have a switch, and then it will go down to the battery box where it will be fused. So I'm going to have to mount the shunt, cut this little devil to length, and crimp an end onto it, and then I can attach it to the shunt. So that's where I am right now. So I'm going to, because of course I'm going to be working right over here, and there's no way you can see what I'm doing while I'm working there, I'll just do these things and show you progress as I go. Well, after much fooling around, I finally got everything on the wall finished. I haven't tidied up the wiring yet, but I'll do that tomorrow. So starting up here, I've got a ground strip that I have to attach the inverter to, but I haven't gotten that far in the instructions yet. This is a Victron 15035 MPPT solar charge controller. It's a smart charge controller, so I'll be able to get readouts from it with my phone. This box has two circuit breakers in it. This one is the solar input to the charge controller, and this is the output from the charge controller to the batteries. And you're supposed to turn on the batteries first and then the solar. So as soon as I get the batteries hooked up, we'll do that. Here's the inverter. Power wiring is connected to it here. The negative wire goes down to a shunt, which is going to be talking to a Victron BMV712 smart battery monitor, which I have but have not hooked up yet. And the positive wire comes down here to a switch for the batteries, and that cables then go down into the battery box. They're just in there temporarily right now. What I'm going to be doing for the next little while is wiring the battery bank. Alright, I finished wiring up the battery bank. This is half of my planned battery bank. So this is 4 105 amp hour deep cycle batteries. So that gives me a little over 5 kilowatts of battery capacity. And if I draw them down by 50%, that gives me about 2.5 kilowatts of battery backup capacity to run the inverter. And it is probably about what we would use in one day if we're using the refrigerator, freezer, well pump, a few lights, and the furnace. So we can get by for about 24 hours with this setup. And I will, in about 4 weeks, buy an additional 4 batteries. This is what my battery supplier had on hand today. So I'll wait a little bit. I'm going to give my credit card a much deserved rest before I buy the rest of the batteries. Now, some of the wires look pretty long, and there's a reason for that. I want all the wires from the batteries to the connection points for the high amperage leads to be the same length. That means the lead from the closest battery to the connection point and from the farthest battery to the connection point, they need to be the same length, and that's about 2 feet 3 inches. When I have all the batteries in the winter, I will have about 2 days, maybe a little bit more, of backup capacity. If we get some sunny weather during that time, it will be extended. And in the winter, my solar array should put out about 1 kilowatt a day, which will extend me by about half a day per day of sunny weather. I did test the inverter briefly last night just to make sure it works. It is not hooked up to AC yet, so I can't test the pass-through. That's on the plan for today. And but it does work, and I ran my refrigerator and my freezer for about 20 minutes just to make sure. It's very easy to do the switch over, and everything is working well. So on the list for today is tidying up all these wires. They're just in there now, but I'm going to go through and put some clips and tie downs in to get them nice and neat. And the only thing left to do on the inverter, other than the AC wiring, is to hook up the case ground. I've got the wire for it, and if you look up there, just above the charge controller, you can see a little bus bar. That's where my ground wire from the solar array comes to. Obviously, it's not grounded right now. I just finished driving a ground stake in the ground outside that wall, but it's raining pretty hard, so I'm going to wait until tomorrow to drill through the wall and feed the wire in. So that's the next step. So tomorrow I'll finish all the grounds. I'll wire out to the ground stake and do the case ground on the inverter. And then we will be hooked up, assuming I get the AC wired into a breaker today. So that's where I am, and I'm hoping to get it all finished off sometime tomorrow. And right now I'm charging off solar, and even though it's completely overcast and raining today, and it's 10 o'clock in the morning, so the sun is in the southeast, my west facing solar panels are putting out about 45 to 50 watts, which is dumping about 1.75 to 2 amps into the battery bank to charge it up. The batteries are brand new. They arrived at about 70% state of charge. So this is a 210 amp hour battery bank at 24 volts. So 70% is about 140 amp hours, so they need about 70 amp hours to be fully charged. And I'm certainly not going to get there today. I think today we'll be lucky if we put in more than 20 amp hours. But tomorrow is supposed to be sunny, and I think by the time I get everything all hooked up, that the bright sun tomorrow afternoon on the solar array will do a good job of pushing the battery bank up toward full charge. At least that's the hope. I should say one other thing about the wiring. The main power wiring from the battery bank to the inverter is 2-aught wire. I used Ancor marine grade cable, and their 2-aught wire has an ampacity rating, because of the very high temperature insulation they put on it, of something like 320 amps, which is well above the maximum that this inverter will draw. The inverter is fused at 250 amps, so the cabling is okay. However, in the battery bank, I used number 2 cabling. Ancor says that's good for about 150 amps, and since this is 2 24-volt batteries, if you will, in parallel, the maximum that should come from either of the parallel strings is no more than 125 amps, and that's when the inverter is in surge mode. And normally it will be well under 100 amps, so the internal cabling in the battery bank is fine, even though it's smaller than the high power cables going directly to the inverter. So that's it. The system is all put together and ready to provide backup power as soon as the batteries get charged up. As of right now, I have about $5,100 in this system. Now that's going to generate an approximately $1,500 tax credit, which will be very welcome, and that will mean that the total cost for the system as it stands will be about $3,600. As I said earlier, I still have to add 4 more batteries. They cost about $170 each by the time you get all of the core charges and recycling fees and that included. So that's going to be about $650 more for batteries, and maybe another $50 for wiring. So $700 more. So I'm going to end up spending about $5,800 on this system, and it's going to generate about a $1,720 tax credit, which I can certainly use. So it's going to end up costing me around $4,000 for this battery backup system. In the summer, my total power consumption averages between 3 and 4 kilowatts a day. My solar array should provide that much power. So the hope is that in the summer I can replace maybe 75% of my power consumption, and over say 4 or 5 months save about $25 a month. Big money, $100 a year in power savings. So that means that if I do that every year, I'll be able to pay for this system in only a little over 40 years. Not bad. Anyway, thanks for watching. Hope you enjoyed this rather long video, and if you did, please give me a thumbs up or a like, and if you haven't, please subscribe to my channel to see more exciting videos as I tinker with things around the house. Thanks again for watching.